Quality education is a human right.
Hey guys, for today's lesson, we will be solving more complex derivative problems. We will be learning the product rule, the quotient rule, and the chain rule in order to solve them. These rules are important because they're found ubiquitously throughout calculus. In the next slide, we will be finding out why the product rule is important. On this slide, first, we're going to prove that both of these equations are the same quadratic. So we start by foiling the intercept form. So we have 5x times 4x, which would be 20x squared, and then 5x minus 7, which is negative 35x, and then 2 times 4x, which is adding 8x, and then 2 times negative 7, which is negative 14. Now we simplify that. We'd get 20x squared minus 27x minus 14. So these two are the same quadratic, just in different forms. So now we will derive both of them, and since they're the same quadratic, they should be the same derivative. So we'll start with standard form. dy dx, and then the derivative of 20x squared be 40x, and then the derivative of negative 27x would be negative 27, and then the derivative of negative 14 would be 0. So we just leave it as 40x minus 27. Now, we'll first incorrectly derive the intercept form, just to prove that we need product rule to find the correct derivative. So if we do that, we have that dy dx equals to 5, that would be the first derivative. And then for the 4x minus 7, it would be just 4. And then 5 times 4 is 20. So now these two are not the same because we didn't use the product rule, which in the next slide we will learn the product rule so that we can finally solve quadratics in the intercept form. On this slide, we have the same quadratic as the previous example. So we already know that dy dx equals to 40x minus 27. But now we need to find the derivative of the other half of the quadratic. So now we need to find the product rule, which is the derivative of f of x times g of x equals to f prime of x times g of x plus f of x times g prime of x. Now the main thing to notice is that we have two functions being multiplied by each other. That's how we know when to use a product rule. In our example, we can see that we have 4x minus 7, and we have 5x plus 2. So we start by having dy dx, and that equals to, now 5x plus 2, we have to derive that. So we get 5. And then we multiply 4x minus 7, because if we look at the rule, g of x stays the same. So now we continue by adding, and then in this time we have 5x plus 2 staying the same. But then 4x minus 7 gets derived, which would just be 4. Now we multiply and then simplify until we get the final derivative. So we multiply 5 times 4x minus 7, which would be 20x minus 35, plus, and then 5x plus 2 times 4, which would be 20x plus 8. Now for the final step, we add them. So we have 40x and then minus 27. So we have that dy dx equals to 40x minus 27. So now we proved that using the product rule gets the same thing as our other example. So in the next slide, we will see another example where we use the product rule. Now in this slide, we have another function. Now the first thing that we should notice is that we have two functions being multiplied by each other. We have 7x squared plus 9x being multiplied by the cube root of x to the fourth. Now if we look at the top of our rule, we have our g of x and we have our f of x. Now, the first step that we need to do in order to facilitate the process is to convert the square root into a fractional exponent. Now, that would be x to the power of 4/3. Now, it's okay if you don't remember this, but this was learned in the first episode, and you could click on the link at the top so that you can remember this process. Now we'll continue with the process. So we have e prime of x, and then we begin to derive. So first f prime of x, so in our situation, it'd be 14x plus 9, and then we multiply x to the 4/3, because if we remember our rule, the g of x remains unchanged for now. So now we add, and then this time f of x remains unchanged. So we have 7x squared plus 9x, and then that's being multiplied by, first we bring down to 4/3, and then in the exponent we have x to the power of 4/3 minus 1. So now, in order to subtract, we change the 1 into 3/3. So we have 4/3 minus 3/3. Now we simplify further until all we have left is 1/3. Now, in order to simplify further, as a matter of preference, I'd put the x to the 4/3 at the front, and then I'd multiply the 14x plus 9. And for this one isn't a matter of preference, but it's necessary. The constant needs to go in the front. So on this one, the constant would be 4/3, and then we'd have x to the power of 1/3, and then we multiply 7x squared plus 9x. So now we found the derivative of p of x. Now in the next slide, we will look at a different example so that we can master the product rule. On this slide, we have a different example, and the first thing we should notice is that we have two functions being multiplied by each other. We have 2x plus 3 being multiplied by x squared minus 2x plus 4. Now, if we look at our rule again, we have our g of x and we have our f of x. Now, we start by having dy dx, or in another notation that we could have, it could just simply be y prime. Now, y prime is the same as dy dx, but sometimes it could be preferable. So now I'll give you a moment to solve this on your own, and then you could come back to check your answers. Okay, so now we'll solve it together. So the first thing we derive is 2x plus 3, which would be 2. And then we multiply x squared minus 2x plus 4, because this stays the same. Now we add. Now it's 2x plus 3 remains the same. Now we derive the x squared minus 2x plus 4. Would be 2x minus 2. Now we can simplify this further by multiplying 2 by the x squared minus 2x plus 4. So we have 2x squared minus 4x plus 8. So now this half is simplified. Now, for 2x plus 3 times 2x minus 2, we could FOIL and simplify more. So 2x times 2x would be 4x squared. 2x minus 2 would be minus 4x. 3 times 2x would be plus 6x. And then 3 times negative 2 would be minus 6. Now our final step would be to combine all like terms. So we start with the x squared. So 2x squared plus 4x squared, 6x squared. Now the x's, we have negative 4x minus 4x plus 6x. That would be minus 8x plus 6x, which would be minus 2x. And then the constants, so we have 8 minus 6, which would just be plus 2. So now we have found y prime for this example. Now in the next slide, we will find out how to derive when instead of multiplying two functions, we're dividing them. On this slide here, we have the quotient rule. What you must notice is that instead of multiplying two functions, we're dividing. So we have f of x being divided by g of x. In the example we have below, let's say that 5x plus 2 is f of x, and x squared plus 12x is g of x. Now, the derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x over g of x squared. Now, if you notice in the numerator, it's very similar to the product rule, but one thing that you must notice is that it's subtracting instead of adding. Now, this is important because it could lead to a crucial mistake. We could see this later on in our example. So we start with y prime equals, first we derive 5x plus 2, which is 5. And we multiply that by x squared plus 12x. Now, after that, we subtract, and we have to keep whatever's to the right of it in a big bracket, because the mistake that students make is that they forget to distribute the negative to all of to f of x times g prime of x. So we won't make that mistake here. So we have 5x plus 2 being multiplied by the derivative of x squared plus 12x, which is 2x plus 12. And in the denominator, we have g of x squared, which in our case would be x squared plus 12x and then that squared. So now for 5x plus 2 times 2x plus 12, we must FOIL so that we can simplify all the way. We have that equals, in the first place, we have 5x squared plus 60x. And then on the right side, we can't forget that we need to distribute the negative sign. So we keep a bracket to remind ourselves. And then we begin to FOIL. So we have 5x times 2x, which is 10x squared. 5x times 12, which is adding 60x. 2 times 2x, so you add 4x. And 2 times 12, which is adding 24. So now that we have that, on top here, we'll just distribute the negative so that we don't forget it. So we have negative 10x squared. 60x plus 4x is 64x. And then 64x times the negative would be negative 64x. And then the 24 distributed by the negative 1 is negative 24. And we shouldn't forget that our denominator stays the same. So we just bring it over. So now for our final step, we must combine like terms, and then we'll have our final answer. So we have that y prime equals, first combine the x squared. So we have 5x squared minus 10x squared. So we'll have negative 5x, negative 5x squared. 60x minus 64x. So we have minus 4x. And then negative 24. And then again, we bring our denominator. So now we found the derivative of y using the quotient rule. In our next slide, we will use another example to master the quotient rule. In this slide, we have y equals to e to the x over 5x cubed plus 17x. So if we notice here, again, we have one function, which is e to the x, being divided by another function, which is 5x cubed plus 17x. So if we look at our quotient rule, we have our g of x, and we have our f of x. So now a quick rule to remember is that the derivative of e to the x is simply e to the x. Now in a different episode, we'll review why this is, but for now, you must simply believe that the derivative of e to the x is also e to the x. This is an important rule to remember because it's present throughout calculus. So now we'll begin deriving. So we start off by having y equals to the derivative of f of x, which would be e of x again. And we have that being multiplied by 5x cubed plus 17x. Now, again, we must subtract and not forget our brackets because as we learned from the previous slide, a student can make a mistake by forgetting to distribute. So this time, e to the x stays the same. And then we multiply that by the derivative of g of x, which in this case would be 15x squared plus 17. And then we close our bracket. And in our denominator, we simply have 5x cubed plus 17x. And then that all together is being squared. Now, out of preference, I would recommend factoring out the e to the x instead of distributing it or just leaving it like that. As we'll find out, it looks better if we factor out the e to the x and if we just leave it or distribute. So we'll begin by taking e to the x out. And if we notice, what we have left would be 5x cubed plus 17x minus, and then we must not forget to keep the bracket, 15x squared plus 17. So now we'll finally begin to distribute our negative. So up top here, we have that negative 15x squared. We distribute the negative to the 17, so that it would be negative 17. And we shouldn't forget, we also need to bring our denominator because that doesn't change. We have 5x cubed plus 17x, and then that is squared. So now for the final step, so that we can simplify this, we just combine like terms in the numerator, and then we'll have y prime. So again, since we factored e to the x, we have that outside, and then inside parentheses, 5x cubed. There's only one x cubed, so 5x cubed is unchanged. And then we only have negative 15x squared. There's only 17x, and then minus 17. And again, we bring our denominator with us. And there we finally found the derivative of y. Now, in the next slide, we're going to review function composition so that we can learn how it's related to the chain rule. In this slide, the first thing we should notice for chain rule is that we have two functions. One is being nested inside the other. So we have f of g of x, and we have the derivative of f of g of x is equal to f prime of g of x times g prime of x. Now, if you don't remember function composition, you could leave down a comment and there could be a separate video revising it. Now, to begin deriving, since we see that there's a radical, we know that it behooves us to switch it into an exponential fraction so that we could derive easier. So we have 5x plus 1. And that's to the power of 5/4. So now, before we derive, we must first identify which is the innermost function. So the innermost function is g of x since it's inside. So if we see inside the parentheses, the innermost one that we have is 5x plus 1. So then what's f? The f is the function to the power of 5/4. So we'll begin deriving so that you can see the process. So we would have y prime is equal to, we bring down the 5/4. And if we look at our rule, g of x stays the same. So we have that's multiplied by 5x plus 1 because it doesn't change. And then to the power of 5/4 minus 1. The power 5/4 minus 1. And then final step that we have to do is that we multiply the derivative of g of x. And if we remember, g of x is 5x plus 1, so the derivative would be 5. So now that we have this, we can begin simplifying. So 5/4 remains the same. And then we have 5x plus 1. And then when we subtract 1, we could do it by having 5/4 minus 4/4. Now, we could simplify this further. So we have 1/4. And we multiply that by 5. Now, for the final step, if we remember from the previous slide, we must put the constants to the front. So we have a 5/4 being multiplied by 5. So that would have 25/4, 5x plus 1, power of 1/4. Now you could switch it back into a radical, but for now we'll keep it like this. Now just a reminder, if you need to relearn function composition from Algebra 2, you could leave a comment and we'll have a separate video learning that. Now in the next slide, we'll have a different example so that we can master the chain rule. So here we have another example. If we can see here, we have two different functions. We have 7x squared plus 2x, and we have e to the power of a function. Now the first part is that we have to identify which is the innermost function. So if we look here, the outermost would be e. So that would be our f. And then 7x squared plus 2x, that's the innermost, which is the second part. Now, before we begin deriving, let's not forget the rule that the derivative of e to the x is equals to e to the x. It doesn't change when you derive. So now we can begin deriving h prime of x. That's equal Then we have our first part. We have that e to the power of 7x squared plus 2x, because the derivative of e to the x remains unchanged. But then we have our second part. So then we multiply g prime of x. But in the beginning, we identified that g of x is 7x squared plus 2x. So here we have 14x plus 2. Now, there's not much to simplify, but just as a matter of preference, so it looks organized, we have h prime of x is equal. We bring the 14x plus 2 to the front, and then we have that being multiplied by 7x squared plus 2x. So we have found h prime of x using the chain rule. Now in the next slide, we'll look at a different example where you could try it on your own and we could review the answers. So on this slide, we have a different example where we have two functions again. Now, before you try it on your own, we'll first together identify which is the innermost function. So if you take a look, we can see that the innermost would be 4x minus x squared, and outermost would be the function to the power of 100. So if we look here, we have that this would be f, and the 4x minus x squared would be g of x. So now you can take a moment to try this on your own and come back to review your answer. Okay, we'll now solve it together. So we could start having L prime of x and having that equal. So we first multiply the exponent to the front since it's the f. We have 100 times. And then if we remember, the 4x minus x squared, which is the g, remains unchanged for now. So we have 4x minus x squared, and then we have that to the power of 100 minus 1. Now, the last step would be to multiply g prime of x, and that would be 4 minus 2x. Now, there's a few simplifying that we could do. So, if we remember, the constant remains in the front, which we already have that. So we just leave the 100 there. Now, we, as a matter of preference, we put 4 minus 2x, and then we multiply 4x minus x squared to the power of 99. So there we have it. We found the derivative of L of x using the chain rule. Now, the next slide will be a little bit more challenging since we'd have to use both the chain rule and the product rule. If we see on this slide, we can see that we're going to have to require both the product rule and the chain rule. The first thing that you should notice is that we're multiplying two functions, 2x minus 3 to the 4th, and x squared plus x plus 1 to the 5th. So since we know we're multiplying two functions, we know that we have to use the product rule to find the derivative. So we'll have 2x minus 3 to the 4th be f of x, and we'll have x squared plus x plus 1 be g of x. So now we begin deriving. So we have p prime of x, and then we have that being equal to, well, the first thing we're going to do is, for now, we'll have box prime. And because if we look at f of x, we could see that we're going to have to eventually use the chain rule. But for now, we'll keep it as box prime. And then we multiply g of x, which in our case, g of x is x squared plus x plus 1 to the 5th. And then the 2x minus 3 to the 4th, we bring that down since f of x remains unchanged. And then again, we'll have a box prime. We're going to have to use the chain rule, but for now, we'll keep it so that we'll know that the notation lets us know that we're going to have to derive still. So now we have the product rule set out. So now we'll have to focus on the chain rule. So if we remember the chain rule, we have to identify which one's the innermost so that we could derive. So we'll start with f of x. So if we have a look at f of x, the innermost would be 2x minus 3. And then the outermost would be the function to the power of 4. So now we know the structure of that one. So we could derive. So before we derive, we'd like to bring down x squared plus x plus 1 to the 5th and 2x minus 3 to the 4th. We bring these two down because we're not deriving them anymore, and we already know they're not going to change for now. So we bring them down so that we could not forget them when we solve p prime of x. So we start off by multiplying 4, and then if we remember the chain rule, the g of x remains unchanged, so we have 2x minus 3. Now, in the exponent, we have 4 minus 1 since we're deriving, so we have 3. Now, we multiply g prime of x. So, we derive 2x minus 3, and we have times 2. So we have f of x derived. So now, we'll look at g prime of x. So, again, the first step would be to identify the innermost. So, if we look here, the innermost would be x squared plus x plus 1. So that would mean that the outermost would be the function to the power of 5. So now that we found those, we could begin using the chain rule. So we start off by multiplying 5. And then we know that it's not being altered, so we could just 5 times x squared plus x plus 1. And then in the exponent, since we're deriving the 5, we have 4, because 5 minus 1 is 4. Now, the final step to the chain rule, so not forget the g prime of x. So what we have is 2x plus 1. So now we have this. We derived everything, and there's few simplifications that we can do. So we'll start with that. We have that p prime of x equals 2. First we bring the constants to the front. So we have 8 being multiplied by 2x minus 3 cubed, and then the x squared plus x plus 1, that remains unchanged. So we keep that the same. So now we'll work on the other side. So we have, again, we have to bring the constants all the way to the front. So the only constant there that we have is 5 on its own. And then as a matter of preference, I would bring 2x plus 1 to the front and have the rest be the same. So we keep this unchanged. So we have our solution. So we have x squared plus x plus 1 to the fourth power. So there we have solved p prime of x using both the product rule and the chain rule. That's all for today's episode, guys. In the next episode, Michael will showcase how to derive trigonometric functions.
If you have any questions or any practice problems you would like to understand better, please comment them down below. During our bi-weekly Q&A, we will tackle these problems from the comment section.
Please like and subscribe so that our videos can reach more calculus students. See you next time, you sleuths.